Hi, everyone. Welcome to Building NLP Applications with Transformers, a live interactive event collaboration between FourthBrain and Hugging Face. Backed by Andrew Ng's AI Fund, FourthBrain helps you take your ML career to the next level. Our cohort-based courses are designed to accelerate your learning so that you can apply the latest and greatest ML approaches to your next AI project. By learning industry best practices and state-of-the-art tools from first principles, you'll be ready to make a bigger impact in your current role or in your new job. Speaking of industry standards and state-of-the-art tools, we've got an incredibly special guest today who's going to teach and show us hands-on the power of one of the fastest growing open source projects on the internet. Before we meet our speaker, let's meet each other. Our small but mighty FourthBrain community is global, and you never know what connections you might be able to make here at today's event. Let's share a little bit about ourselves in the chat and where we're tuning in from. I'm Greg, the Director of Product and Curriculum at FourthBrain, and I live in San Francisco. What do you do? Where are you from? Let's keep the intros coming in the chat. Wherever you are, you've probably heard of Hugging Face, the AI community that's building the future. And if you haven't yet experienced their amazing Transformers library, you'll have the chance to follow along line by line as we see a full end-to-end ML application example built out during our session. The code will, of course, be shared with all of you as we get started. Did I mention that Hugging Face is worth $2 billion and just raised $100 million last month to build the GitHub of machine learning? We should all be watching this space. A quick note on the process today. We'll hear from our speaker, who will be presenting some important context and high-level overview about Hugging Face and Transformers before he dives into a live demo. Following the demo, I'll ask a few questions, and then we'll open it up for about 20 minutes of Q&A from all of you. So if you see anything that piques your interest, please drop your question directly in the YouTube live chat. With that, I'm thrilled to give a warm welcome to Julien Simon. Julien is currently Chief Evangelist at Hugging Face. He recently spent 6 years at Amazon Web Services, where he was the global technical evangelist for AI and machine learning. Prior to joining AWS, Julien served for 10 years as CTO and VP of engineering in large-scale web startups. We're really excited to have you today, Julien. Take it from here.
Thank you. Thank you very much. And again, thank you for inviting me. Kudos to FourthBrain for building such a great series of events. And thank you, everybody, for joining. So my name's Julien. I'm based outside Paris. And I'm going to try and introduce you to the joy of building machine learning applications with transformers. So if you have a machine learning background, great, stick around. I'm sure you're going to learn something new. If you don't have a machine learning background, or if you don't have it yet, if you're just starting, stick around. I'm going to keep this interactive, high level, and you can follow along. You can ask all the questions, and we'll try to answer as many as we can. So get a cup of coffee, or whatever you fancy. You're probably going to need it. And before we jump into the code, let me, of course, share my screen. And I just want to show you a handful of slides. And I promise it's not a lot. I actually have 4 slides, so including the title slide. Okay, so that shouldn't be too painful. Just to give you a sense of who Hugging Face is, what we're building, and why we're building it. Okay, so you have my contacts here. You can take a screenshot of that if you want to reach out later. You can drop me an email. You can go and check some of my YouTube videos, my blog. I'm generally easy to find, and I'm more than happy to connect and help you out after the session, and introduce you or your teams to what Hugging Face can do for them. Okay, all right, let's get started now. So the first thing I think I should point out is how deep learning has changed over the last few years. So deep learning kind of exploded onto the stage, I would say, from 2012 to 2015. especially in the enterprise world. And of course, people starting adopting it, adopting neural networks and open source libraries and infrastructure, and trying to put everything together. And I call that deep learning 1.0. And deep learning 1.0 is fine, but if you've been in the field for a couple of years, maybe you've grown frustrated of how difficult it actually is to get your models at the quality level that you want and in production, right? And manage them in production. So over the last 2 years, we've seen some new technologies popping up. And well, those planets are now lining into what I'm calling deep learning 2.0. And the first planet is the one we're going to spend a lot of time on today. It's, of course, the transformer architecture. So you may be familiar with traditional deep learning architectures like convolutional neural networks or recurrent neural networks. And, don't get me wrong, these are still great. They still work for a lot of use cases. However, for the last 2-3 years, the transformer architecture has proven to be very, very efficient over a wide range of use cases, from natural language to computer vision, to speech processing, to time series. And, we have customers who even apply transformers to life sciences domains, etc., etc. So transformers, again, are becoming the new standard way of doing machine learning. And we'll see a lot of code on that today. In deep learning 1.0, one of the main tasks you had to do was actually to build a huge data set to train your models on. Again, images, text, speech, etc. And again, that's, if you've been doing this for a living, it's a lot of time and a lot of effort. We see a shift to a technical transfer learning, where instead of training large models from scratch every single time, we relied on off-the-shelf models that have been pre-trained by different companies, different teams out there, and shared, so that you can start from the pre-trained model and maybe use it as is. Maybe it's just good enough that you can use it directly, or maybe you're going to train it just a little bit on your own data, and in fact on a little bit of data. You don't need a lot. And so this technique is called transfer learning, and it's really changing the game. It's really speeding up the project lifecycle. So far, most of deep learning has been trained on GPUs, right? And GPUs are great. They're, massively parallel chips, and they still work very nicely. But we see a new generation of hardware popping up. Hardware accelerators for training and for prediction that have been specifically built for machine learning, which, with all due respect, is not the case for GPUs. I remember a time where GPUs were used for 3D games. And I guess they're still used for that a little bit, although I have no time for that now. But seriously, ML hardware is something really, really interesting. Companies like GraphCore, Intel, Habana Labs, and a few more are really building some very, very interesting chips that accelerate prediction and training quite significantly. And the last bit is always going to be tools, right? And of course, we've had tools before. We've had some really awesome open source libraries like TensorFlow and PyTorch and others. But it's fair to say, especially in the early days, they were difficult to use. And that's why I'm really putting the focus here on developer tools, because we really think that every application developer out there should be able to pick models, evaluate them, test them, and deploy them in their own applications, even if they don't have any machine learning background. Okay, so we really put the focus on building simple tools that hide the complexity, give you all the flexibility that you want if you really need to have it, but that also make it really simple to use and deploy those models. Okay, so that's really what Hugging Face is all about: promoting transformers architecture, changing the game with transfer learning and a huge collection of pre-trained models, accelerating the workflows for training and prediction, and building simple tools that anybody can use, even if they don't have a machine learning PhD, right? And even if you have a machine learning PhD, that's great. Congratulations. I don't. And you can go and tweak even further. So I just want to call out that main project, which is the one we're gonna discuss today. It's the Transformers project from Hugging Face. It's one of the fastest growing open source projects ever, thanks to the adoption of the community. You can see the GitHub stars here for Transformers, which is the yellow line on the left-hand side. And we can compare the growth to some other awesome projects. And it's pretty funny and even shocking to see that our popularity is growing faster than Node.js or Kubernetes, not to mention other AI and database related projects. So we're all very humbled by this. We thank the community for this, and we really intend to keep the good stuff coming. And it's not just the community. We see analysts also catching up. If you read the latest State of AI report, you probably saw that, I guess slide 3 says that transformers are emerging as a general purpose architecture for ML. So it's really not just NLP. And you could say not just deep learning anymore. It's really becoming the de facto standard for ML. And this is confirmed by the Kaggle survey that shows that traditional models like convolutional neural networks, recurrent neural networks are increasingly less popular, while transformers are increasingly more popular. So there's really that shift happening in the machine learning community right now. And just to give you numbers, we have over 1 million model downloads from the Hugging Face Hub every day. That's a good number. And actually, just a couple of days ago, we had over 100,000 users in a single day. So that's a good metric. So lots of folks use us. We're again very happy and very humbled, and this shows the value of the transformer architecture. The last slide I want to show you before we move into the demo is to give you kind of the family, show you the family picture. Today we're going to focus more on the open source libraries, but there's a whole portfolio of projects that we work on. So we have datasets and models that we host on the Hugging Face Hub, our website, which you will see in a minute. And this is the slide that's never, that's always outdated, because datasets and models are added every minute. So that number here is always wrong, but that's kind of the ballpark. From that, you can actually go and use different solutions for training. Of course, you can train on your own machine using the Transformers library. We have another open source library called Optimum for hardware acceleration on training and on inference. We have an AutoML product called AutoTrain. You can then move on your models to spaces, which I will actually show you today. A very cool way to build and demo your machine learning models in ML applications, web applications. And we have the Inference API, which is a managed hosting service for models. We'll take a quick look. And of course, if you like to work in the cloud, we have a partnership with AWS, which makes it easy to train and deploy models on Amazon SageMaker. And as of a few weeks ago, we also launched a service on Microsoft Azure, where you can literally one-click deploy any model any NLP model from the hub to manage infrastructure on Azure. So that's kind of the family picture here. We'll look at some of those blocks. And if you're curious about the other stuff, feel free to go to our website, huggingface.co, and you'll learn more. And of course, you can ask me questions. Okay. All right. And if we have questions already, please interrupt me and ask questions. Okay. All right. So let's get to the demo. So this is the Hugging Face Hub. Okay. that lives at huggingface.co. You can sign up in a minute. You just need to give a username and an email address and a password. Okay, so that's all it takes, and it's all free to use. Okay, which is great. And on the hub, we have models and quite a few of those. You can see every time I reload the page, that number increases, which is pretty crazy. And we see models for a whole bunch of task types, from natural language processing to computer vision to audio. Oh yeah, even reinforcement learning now. And we'll look at a couple of those models in the code, but in a nutshell, what you see here is what we call the model page. Each model is managed in a Git repository, which you can clone using the Git workflow, or which you can use with our open source libraries. Okay, and that's what we'll do in the demo. Okay, the model card gives you information on what the model is, what it's been trained on, some metrics, generally any information that you'd like to have. And we see the same for datasets. Okay, about the same thing. And of course, we have all those nice tags on the left that let us find, models for, I don't know, summarization in French. And yeah, we can see those models here directly, and we can go and work with them. Okay, so the hub really doesn't need a lot of introduction. Just create an account, go and try it out. Let's try and solve a real problem now. Okay, so the problem we want to work on here is part of a series of notebooks that I'm currently building. So still work in progress, and I suspect it will be work in progress for the next 10 years. So apologies if you find some problems in there, but feel free to create an issue on the GitHub repo, which I'm sure has been shared with you, and I'll be happy to fix it. Okay, so so this is kind of a self-paced workshop, and I've selected a few bits and pieces to give you an introduction on transformers. Okay, so first of all, we need a problem to solve. Okay, and I insist on this because you wouldn't believe the number of customers that I talk to who kind of neglect this first step, and when I ask them, okay, so what do you want to do with ML? What do you want to do with Hugging Face? Sometimes I hear, oh yeah, we want to, test the waters and see what the technology can do. And I'm like, yeah, well, that's not great. I think that, if you have 1 million model downloads a day and thousands of companies and, tens of thousands, even hundreds of thousands of people using us, no offense, but it's safe to say the technology can do quite a bit. So please find a problem in your company, in your business, in your organization, and let's see if machine learning and transformers are a good fit. Okay, so here, in the interest of time, of course, I've selected a problem, and well, I worked for a few years at Amazon, so I'm still a little bit obsessed by all things Amazon, and you'll have to excuse me for that. So here, let's pretend that we work for a company selling shoes. Okay, and we have lots of different shoes, tens of thousands of products. And we want to understand the voice of the customers. Okay, so we want to collect customer opinions, customer reviews, customer tweets, anywhere they are, and we want to score them. Okay, we want to get a feeling of, okay, what are people thinking of our products? Do they like them? Don't they like them? We want to figure this out. Okay, that's a really, really common problem for a lot of companies. Okay, so we could do, many different ways, and here we're gonna keep it simple and say, okay, let's score those reviews just like Amazon does. Okay, so we want to get a piece of customer text, and we want to score it from 1 star, which is awful, as you can see here, and all the way to 5 stars, which is great, right? No explanation needed. Okay, so we want to build a model that knows how to do that. Okay. So now the problem is defined as, given an English language product review for shoes, I want to predict a star rating between 1 and 5 to understand how satisfied the customer is with the purchase. Okay. And for you folks out there who are doing or want to do machine learning for a living, I cannot insist enough on how important it is, right? Get this from your business stakeholders, from your customers. What is it that they want? Okay, if you can't write this thing on the whiteboard in plain English in one sentence, keep pestering them, because the problem is either not defined enough or too complex. It should be as clear as this, right? And it's actually good exercise when you work on a machine learning project to actually pause for a minute and say, okay, can I actually state this, right? Can I actually say what I'm working on in one single sentence, right? Sometimes it's not so easy. Okay, so that's the business problem. So now from a machine learning perspective, what we want to do is, we want to train a multi-class classification model for product reviews, okay? Given a product review, we want to classify that review according to 5 categories, right? 1 star to 5 stars, okay? So it's a multi-class classification problem. And as we know, this will give us 5 probabilities, 1 for each class, okay? So that's what we're trying to do here. So as we know, we have pre-trained models and transfer learning and all that good stuff that I described. So that's the starting point now, okay? Deep learning to 0, remember? So do not go and rush and look at neural network architectures and building data sets, etc. You need to be lazy, which is a virtue in this case, and you need to go and look for models, okay? So you can go on the hub, you can look for text classification models and sentiment analysis models, and I'll let you explore those in the interest of time. There are a lot, okay, that we can start from. Although there's probably no model that knows about star ratings, okay, we could probably find sentiment analysis, negative, positive, etc. But star ratings is just a little bit too specific. So, okay, we can start from something that's close enough and then teach it how to predict star ratings, right? Okay, so models are out there. Data sets. Can we find a data set for shoes, right? And as unlikely as it is, absolutely, because we have on the Hugging Face Hub the Amazon US reviews data set, which is really interesting. It has millions and millions and millions of product reviews that actually come from Amazon.com. There are some different languages in there, but the largest part is really US reviews. And there's a subset in these data sets that's shoes, right? And we can explore this on the hub. And maybe we can take a look, right? So we can see all the different splits for this data set. And yeah, here we are. We have shoes, okay, and there's quite a lot of data in there. So you could say, well, if we're a shoe retailer, maybe we have data already, and fair enough, and you should absolutely use this. But nothing beats starting from data that's already there, that's already been prepared, that's already in the right format. So if you want to build a proof of concept in a matter of hours or a couple of days, that off-the-shelf data is an excellent place to start. Okay, but of course, over time, you should also add your data to make your model even better. Okay, so it looks like we're in good place. We have some models we can probably start with. We have some data sets, and now we need to put everything together. Okay, so let's go and do that. Let's change notebooks. Okay, so the first thing I'm going to do here is of course to look at the data set, and to do this, I'm going to use the Datasets library, which is one of the Hugging Face libraries, and you can find it just like everything else on GitHub, right? And so this is a Python library that makes it super easy to download and process and save and share data sets to be used with transformers. Okay. And so we'll look at a couple of APIs here. So for example, here, that one line of code, let me zoom in maybe just a bit. That one line here is enough to download everything. Okay, so I'm just downloading that Amazon US reviews data set that we just saw. We're grabbing the shoes split here. And we can see it's quite big, you know, it's over 2 gigs and it's got 4.36 million reviews, right? So that should be enough. And actually it's way too much for this purpose. So we'll just go and say, nah, just give us 10%, okay? And you can see how easy it is to do that, okay? Just download and say, hey, give me 10%. So now accordingly, we have about 436,000 reviews, and we have a bunch of features, okay? And if we look at one example, okay, here's a review, right? So we have a customer ID, a review ID, we have a product title, we have the product category, which is always going to be shoes here, of course. We have the star rating, okay, which is interesting. And we have the review body and the date, okay? So some of that stuff could be useful. Like, for example, the title, you may want to take it into account, but for simplicity here, I'm just dropping everything except the review body and the star rating, okay? And I can very easily do this with the dataset library. So just drop all the other columns. So now what's left is this, right? Just, you know, out of precaution, I'm going to check that star ratings are what I think they are. Okay, so the unique value should be 1, 2, 3, 4, 5, which is great, but you never know, right? So it's always good practice to check that, you know, you don't have a star rating that says, you know, 999 or something, because if you have 1 or 2, I guess that's not a big deal. But if you have like weird values or missing values, you probably want to deal with those. Okay. Another thing you may want to do is to see how balanced the data set is. Okay, you know, data set imbalance can cause very serious problems for classification models, because in a nutshell, if one class is overrepresented, then it's going to introduce some kind of bias in the model where this class is predicted more favorably than the others with a better accuracy. And we don't want that. We want all the star ratings to be predicted equally well, hopefully. So if we look at the unique values here, we see that actually we have a ton of 5-star ratings. So I guess you can only buy great stuff on Amazon.com, but it's you know, it's doubtful. There are some bad reviews as well, but you can see that ratio between, you know, like the 1-star and the 5-star is over 10x, and that's probably a little too much for comfort. So what I'm going to do is, and I'm not going to go too deep in that code, I'm just going to rebalance that stuff. I'm going to keep just 100,000 reviews, which should be more than enough, and I'm just going to keep 20,000 for each star rating. Okay, to give each of those classes a fair shot at being understood by the model, right? So now my data set is 100K reviews. Now I have another problem here. Star ratings start at 1. And like many things in IT, we prefer to start at 0. And actually we have to start at 0. Class labels must start at 0, okay? So what I'm doing next is I'm just decrementing all the star ratings by 1, okay, to shift them from 1.5 to 0.4, okay? Otherwise, my training job is going to fail in very ugly ways with very weird error messages. So we don't want to do that, okay? And again, I can write this small function and apply it to the whole data set using the datasets library here, right? That map function just applies the decrement stars functions to everything. Okay, last thing I need to do is to rename the columns to what the model actually expects. So the text should be called text, and the labels should be called labels. So again, I can rename the data set very easily, just like that. So now I have something that looks very nice. And I just need to split it for training and validation. Okay, 90% training, 10% validation. Okay, so you can see how easy the datasets library makes it to process that stuff. You could also use the usual tools like pandas and so on, which Datasets actually use under the hood. But this is very, very, very pleasant, very flexible. And there are many more APIs that I didn't cover. So I can save that to disk, to local disk, and I can very easily push it to the hub, right? Just like that. This requires that I've logged in to the Hugging Face hub using the Hugging Face CLI. All the instructions are in the notebook, okay? And so that will push my training split and my test split to the hub. And now if I go to the hub, I should see my data set here. If I can open that page, come on. Let's try that again. Ah, interesting. Okay. Let's go and look for this data set here, maybe. Oh, here it is. I don't know. Something got slow for a second. Okay. Yeah. So we can see the data set and we can browse the training and test splits. Yeah, it's all in there. Okay. So this goes to show, it's pretty easy, again, to get data from the hub, push it back to the hub, etc. Right? So now I've got a data set. And sure, I could have used a Git workflow to do this, okay? Creating a repo on the hub with the command line, and then using Git to add my files that I saved locally and push them to the hub, okay? Same thing. Okay, so now that we have data, we can go and train. So let's try that. And now we're going to take a look at the transformers library. Okay. So the training code here is really simple, thanks to this high-level API called the trainer API. Again, that's what we're going to use today. So first, I need to start from a model. So I've decided I was going to start with this one. It's called DistillBERT. So it's an optimized, it's a lightweight version of the BERT model, which I'm sure you heard. Okay, and I'm going to start from this. It's been pre-trained on a very large English language text corpus, and I'm going to just configure it for text classification and train it on the data set that we've just processed. Okay, so I've got some basic parameters. How many epochs am I going to train for? Here, I just go for one, which is not enough, but it's to keep my training time short, okay? The data set has 5 labels. I have a few more parameters here. And well, I'm in a different notebook, so I need to load the data again. So I could just load it from the hub, just like we've done, or I could load it from local storage, same thing, okay? Just go and grab that data. Again, remember 90,000 samples for training, 10,000 for validation. Okay, this is what the data looks like. Looks okay. I can define a compute metrics function that will compute machine learning metrics after each epoch or after a certain number of steps during training. So here, I'm using the usual ones, accuracy and F1 for classifications. Classifiers is a good choice, precision recall, but you could add anything in there, okay? All right, and then I'm downloading the model, okay? So that DistillBERT model, I'm just downloading it from the hub. And this DistillBERT model is just a generic model, and I make it specific for sequence classification, so text classification, by using this built-in object here, okay? So really saying, hey, go grab that DistillBERT, slap a classification layer at the end of it for 5 labels, and that's the model I'm going to use, okay? And likewise, I'm getting the tokenizer, which I'll use to convert the natural language text into integer tokens that are actually used for training, okay? And in fact, that's what I'm doing on the next in the next cell. I'm tokenizing the different data sets. Okay. Again, if you're not familiar with tokenization, what we're doing here is converting each word, each punctuation sign in the data set into an integer token that maps the vocabulary that the model has been trained on. Okay, models have no love for strings, they want numbers. Okay, so tokenization is the way to do that. Okay, and now we have a training set. So I can actually get rid of the text. By now in the data set, I only have my tokens and my labels. Okay, so how do we train? Well, we define some training arguments. So how many epochs we want and those different parameters, the learning rate, how often do we want to save the model in training, etc., etc. Right? Some of these are completely optional. Actually, you could probably pass just an empty training arguments here and use reasonable defaults. The one I want to call out is this, because as you can imagine, we're going to push the model back to the hub once we've trained it. And this is how you do it. You give it a model ID, right? So that's my username, and this will be the model, the repository name, the model name, so to speak. Okay. All right, and then I just use this trainer object to put everything together. So, okay, the model that I've loaded, the training arguments we've just seen, the tokenizer, the metrics, the training set, and the validation set. Okay. So as you can see here, we're not writing training code. Okay, we're just using high-level objects that make it easy to train. We're not writing TensorFlow code. We're not writing PyTorch code. All that stuff is encapsulated inside the trainer object, right? Which is why I like it, because for a lot of problems, we actually don't need to write the framework code. We just want to grab a model, set some parameters, feed it some data, and train. And that's what we're doing here. Okay, so I'm calling train. This notebook here is running on a machine with a GPU. So I'm running for 1 epoch on those 90,000 training samples. This thing lasted for 25 minutes. And I see my different metrics, right? That thanks to the compute metrics function. So I see the accuracy, I see the F1 score for each one of the classes, etc., etc. And 57% is not awful. It's not great. Keep in mind, we have 5 classes, right? So 57 for a binary classification model would be awful, because it would almost be as good as random. 57 for 5 classes is promising, and we could certainly get higher if we train for a little longer. Okay. Yeah, so we could evaluate that model against different data sets. But let's say we're happy with this. So again, I can save the model locally, and I can push it to the hub, exactly like we've done for the data set. So now, if I go and click on this, I see this wonderful model page. And believe it or not, all this stuff which we call the model card has been created for me automatically, right? So I see my metrics, I see my hyperparameters, etc., etc. I even see the versions that have been used to train this, and all this has been automatically created by the push to hub API, right? And this lives inside this markdown file, which is part of the repo. Okay, and we'll find the same information in there. Okay, so push to hub is really cool because it lets you save your work back to the hub. It lets you share it, and it fills in a lot of information that's pretty handy. And of course, we have the lovely inference widget, which lets us test this. And let's go and try it. So I can try this thing in place. Okay, so I can load the model on demand on infrastructure managed by Hugging Face and get a prediction right there. Okay, without having to write anything. Okay, so that's pretty cool, I think. All right, it's a healthy big model, so it's going to take a few seconds. There we go. Okay, so label 4 means, remember, it means really 5 stars. And yes, I could have configured my training job so that, yeah, I have more descriptive labels than these, but I didn't do it for now. I will. And so this tells me that this short review is 74.4%, 5 stars. Okay, so pretty good. It's a positive review. Okay, so that's what you get when you do this nice push to hub thing. Okay, so you should absolutely do it. And by the way, if you want your super fancy model to stay secret, you can do that too. Okay, by default, all these are public, but if you go to settings, you could click on make this model private, and no one will actually be able to see it. Okay, but I guess shoe reviews are not super confidential. Again, we could have used the Git workflow to do this. We could have created a repo. We could have cloned it, added the files, etc., etc. Okay, and if you didn't use push to hub, right? If you use that Git workflow, of course, you can go and create a model card yourself. Just add the README file, and you can even do this. You can edit the model card on the website too, right? But I think push to hub is just the best way to do this. Okay, so now we have a model. How do we predict with it? Well, the absolutely easiest way to do this is to use this API in the Transformers library called pipeline. It's a one-liner. You create that pipeline object, pass the task type you want to predict for, and the name of the model. Okay, so here I want to grab my nice DistilBERT model that I just pushed, and I want to use it for text classification. Okay, and once I have the pipeline, I can just use it just like this to predict. Okay, and this will give me the top result. Okay, so here this tells me this review is almost 83% 1 star. It's very, very negative. On the contrary, this one is quite positive, right? And it's a 5-star review. So you start to see that workflow. Okay, remember that slide I showed you here, and maybe just to make the point. Okay, how fast you can iterate on this. You know, grab data sets, grab models, train them, push them to the hub, download them again, use them again, etc., etc. That's really what we're trying to do here. Okay, and that's really what I mean when I said developer tools. We want to make it simple. We want to make this as simple as writing code, and you know, not as difficult as writing machine learning code. So if you want a little more control, you can also load the models using the auto star classes. And for example, here, you know, we download the model for sequence classification from the hub. We download its tokenizer. And now we can do every step manually. Okay, so we can start from a couple of reviews. We can tokenize them. And now you see what those tokens look like. Okay, integers, fascinating. And we can pass those to the model, and we can grab the outputs. But now the outputs are activation values. Okay, they're logits. So we need to apply a softmax function to those logits to make them look like probabilities. And now we can see the first review is 83% 1 star, and the second review is 64% almost 5 stars. Okay, so the pipeline is just the simplest way. And if that's all you need, then great. You just save yourself a whole lot of trouble. If you want to go a little deeper, of course, you can load the models and use them like this. And there's still, you know, PyTorch or TensorFlow models. So if you want complete control outside of anything Hugging Face, of course, you can load them as PyTorch or TensorFlow models and work with the frameworks. But that'll be a little more complex. Okay, so here I predicted locally, but how do I actually deploy somewhere that I can predict and that my apps can predict? And this is where the Inference API comes in. Remember, I mentioned it. And the Inference API is a managed service from Hugging Face. And this is how you use it. You build a URL for your model. Okay. You pass a header that contains your Hugging Face token. And yep, you won't see mine, sorry. You can find your Hugging Face token in your account settings. You can create many tokens and revoke them, etc. And then you just run a vanilla HTTPS query on this, okay, passing your payload, right? And that's what we see here. So not only does this predict, this will actually load the model on demand. Okay, so remember we saw that in the inference widget here. The same thing, the inference widget is actually powered by the Inference API, as you can imagine, and we're going to see the same thing here. So when you run this query for the first time, you're going to get a message that says error, model is being loaded, come back in 20 seconds, something like that. Okay, and of course you can pin the models so that they stay loaded all the time. Although I have to say you need a paid plan to do this. But you can use the Inference API for free just like that, but the model gets loaded and unloaded regularly, okay? But for dev and experiments, it's just fine, okay? So in this notebook, we started from the data set that we processed. We grabbed a language model for English, a Dilbert model, which we kind of instantiated for text classification. We used transfer learning and trained it for a short period of time on our data set. We predicted locally in a few lines of code, and we deployed it with the Inference API, right? How much of that is machine learning exactly? Well, you could say, okay, yeah, maybe there's a bit of tweaking here, but generally, did we worry about machine learning here? Well, not machine learning code for sure, right? It's more about, putting all those Lego bricks together and getting them to work and then deploying and predicting, okay? So this is quite faster than the previous way. All right, the last thing I want to show you, keeping an eye on the clock here, is how do we make this look good? Because imagine you had to demo this to your, marketing director or a business person who doesn't really have any technical background. Imagine you're doing that same demo I'm doing right there. They're going to be very confused. And this looks nothing like what they had in mind, right? And they'll probably say, but, all I really wanted was a simple web application that, we could paste customer content into and get results. And you're showing me that Jupyter thing that I don't understand. It's full of code and numbers, and no, that's not what I wanted, okay? So fear not, because this is exactly what Spaces is all about, okay? So what your users have in mind is probably something like this, right? They want to see a simple app that they can test just like this. Okay, we're going to do that again. Oh yeah, and it even shows me stars. So that's what I wanted, all this time. You showed me silly floating point numbers. I really wanted to see stars. So this is a Hugging Face solution called Spaces. And in a nutshell, it lets you build a web app using a web framework, which could be either Gradio, which I'm using here, and Gradio is now part of Hugging Face, or Streamlit, which is another framework. So you build your simple app, you push it to Git repo, right? Start to see the pattern here, and it fires up an application on managed infrastructure, okay? So you don't need to worry about servers. You don't need to worry about anything. You just write that code, push it to the repo, and bam, and it starts. And you can demo it. Okay. Needless to say, this is a silly, simple UI. You can find probably thousands by now. If any one of you has been playing with the DALL-E mini model, or if you watch this, it seems to be everywhere now, from car pictures to politicians to, so if you saw a DALL-E mini demo in the last couple of weeks, it's fair to say you saw it on Spaces, right? So there are some really, really good ones here. But in the interest of time, I'm just showing a small one, right? Okay, so let me get back to that space real quick. Okay, so how much code is this? Well, we could look at here. Okay, 15 lines. Okay, it's all it took. Imported Gradio, imported the pipeline API, which we saw from transformers. Created a text classification pipeline using the model we fine-tuned. Okay, that exact same model here. Creating a very basic interface in Gradio with a text input and a text output, and an action, right, which is that button that I clicked, which will call the predict function, right, passing a bit of text, which is, of course, the input box. And what am I doing here? Well, you already know what I'm doing here. I'm classifying the review, okay? And I'm actually, the most complicated bit here is actually extracting that label, right? But that's pretty typical. The UI stuff is usually where it takes more time, at least for me, right? It's really extracting this thing, or no, it's the pipeline value I should show you, right? Yes, it's extracting this and turning this label _4 into 5 stars, right? And I'm sure there are better ways to do it than here, but okay, this is my solution. Just taking that star emoji and displaying it as many times as the label says, okay, and returning this value, which gets displayed in the output. So there you go. This is what it took: 15 lines of code, creating a space, a repository, cloning it, adding and committing my files, which is really the app file here, nothing else, pushing it, and as we say, voila, you have that app, okay? And now if you show that stuff to your stakeholders, well, of course it looks, it looks friendlier. Now they can relate. And again, this is a very simple one. In the interest of time, you can make it look much nicer. You can have different models here. I'm only using this model, but I have some other demos with 4 or 5 models that collaborate to build something more complicated with a richer UI. But now you're speaking their language. Now you're showing them the model in action. You can have even a mock-up of your, maybe your own website here, mock up that web page, add the model to it. And now you can quickly get feedback and iterate on the original business problem that you had, which was, given English language describing a product, can I easily get a result on how satisfied the customer is with that. And this is really what we've done here. Okay, so we started from a data set and a model, right? We prepared the data set using the Datasets library. We trained a model with the transformers library, okay? We deployed it locally. We deployed it with the Inference API. And finally, in 15 lines of code, we built a small web app that showcases what the model does, okay? And how much time it will take you to do this depends on, how familiar you are with the libraries. On your first try, maybe a week. On your second try, maybe a day, because you can reuse a lot of code. You can see a lot of that code is totally generic. And pretty quickly, you can do this stuff in hours, right? The training time will be the longer bit. But if you work with off-the-shelf models, you don't even have to train. You can just build your space, deploy it, get some user and customer feedback on it, and then go back to training and fine-tuning and adding your own data and getting more accuracy, et cetera, et cetera. And so once again, that's what we're trying to build here. We're trying to build that wheel, that collection of tools that lets you spin that wheel as quickly as possible and as efficiently as possible. Machine learning projects should be done in a matter of days, not in a matter of months, and certainly not years, okay? And be extremely iterative. And I think this is what I try to show you today, right? One last thing, obviously, a few links. So feel free to take a screenshot of that as well. So if you want to get started, you should absolutely go to huggingface.co. And we have a Transformers course, which goes deep into the libraries that I showed you today. You can ask questions on the forums. And we also have some commercial offers if you need expert support, if you need private deployments, we can also do that. So feel free to get in touch, and we can take it from there. Okay. All right. Well, that's what I wanted to tell you today. I hope this was useful. Again, feel free to reach out later if you have questions or if you'd like to know more. And I want to thank again FourthBrain for inviting me. This was really a pleasure. And well, back to you, my friends.
Yeah, thank you so much, Julien. This was really an amazing demo, really end to end, truly. And, I want to just rapid fire a couple questions that we got from our audience. Because it seems like you answered quite a bit about how to get started as kind of learning these things. And I really love your idea of like, maybe it'll take a week, then maybe a day or two, and then a couple hours. And that's the speed of iteration today. So, Ritu was asking, like, so it seems like Ritu works in the semiconductor industry, and he's looking for something like silicon data, like it seems like raw material data. So it's sort of a unique application. And it brings up the question, like, have you seen many places that, if they're really trying to get started with Hugging Face, that there's just nothing there on Hugging Face for them, and you have to collect data first?
Yes. And that's what I hinted at some, very radical fields outside of, hey, let's classify images and let's classify tweets. And yeah, I'm actually working with a semiconductor company. I can't name them, as you can guess, but and they see the value in transformers for code generation, and that's all I'm going to say. Otherwise, black choppers are coming my way. But Richard can probably relate because he's in the field. And yeah, it's they have no data whatsoever. So I think the first step is finding a model and a problem that are similar. Okay, so you have some models out there to generate Python code. Okay, similar to GitHub Copilot, and I mean there are some open alternatives to that, and that's the first step. And you can see, well, you can get familiar with the problem. Say, okay, what does it mean to generate working code? What kind of data do we need in the first place? What kind of model do we need in the first place? And you can start from stuff that's readily available out there. Same for financial documents. Same for domain-specific problems. And if you convince yourself that, yeah, this thing works, then, okay, you have to go and say, now, if we want to apply this to our own data, okay, where's that data and how do we prepare it in a way that we can feed it to transformer models? And I'm not going to lie, that's a bit of work. But if you have a target in sight, it's much easier to go to your stakeholders and execs and say, listen, I need folks and I need a team to dedicate themselves to doing that for X weeks, because we know we're going to get there, right? Because that fast experiment on a similar domain showed you that it could work, instead of just going in the dark like a bunch. It's like the hobbits in Shelob's cave, right? It's a tunnel. You're not sure what's in there. You're not sure you're making it to the end of it. Okay, we kind of bring some light to that tunnel, telling you, yes, you'll be safe. There's going to be work on the way, but the problem you're building here, your problem you're trying to solve, can be solved. And that's typically part of the expert support we do for companies as well. We show them that path.
I see. Okay, so yeah, I mean, we've got a number of like technical detail questions that I'm going to encourage our audience to reach out to you directly about? So,
Yeah,
King,
or the Hugging Face forum is just a great place. Like if you go to discuss.huggingface.co, everyone's welcome. Like, don't, especially beginners. So go ahead, ask the questions. The whole team is reading this and answering 24/7 because we're pretty much in all time zones. So yeah, go ahead, ask all your questions in the forum. And if you have questions you can't get answered, then ping me.
Yeah, great. Yeah. So, Kinga and Asim and Pratibha, and even Yiping, these are great sort of transfer learning specific, architecture specific questions. And if you can't get those answered in the community forum, then definitely ping Julien. So, so Christopher had one great question that I want to kind of start wrapping up with, which is like, where can I learn more about controlling access to data sets and models and spaces? So Christopher's thinking about cases where the developers in company A are interacting with stakeholders in company B.
Okay. Yeah, that's a good question. So that's part of that's a part I didn't cover. I really want to focus on the libraries today, but the hub the hub website, as a role-based access features. So as an individual user, you can make your models, you can make everything public or private. Okay, so that applies to models, data sets, spaces, etc. And we also have this concept of organization. So let's say my company is building model that FourthBrain uses, and we want to keep everything private and discrete and non-public. So I would create an organization on the hub for my company. So my dev team would be in there, okay, and it's all private, and only the dev team can work with the artifacts in there. And Greg, you could be invited. You could be part of the FourthBrain organization, okay, and you work on your own stuff in there that I can't see, but I can invite you to the org as a read-only member, okay, and give you appropriate permissions so that you could actually fetch stuff from the org, and it's all based on tokens, etc., exactly like we saw for the Inference API, so that you could grab those models, put them into your own org, and do whatever you want to do with them in there without me seeing. So that's part of the hub. And for increased security and compliance, this is where companies ask us to do private deployments. Okay, so we actually deploy the hub privately for companies, either in the cloud or on premise, because they have very strict requirements. They cannot use multi-tenant applications, and they have to run on infrastructure that they control. So we do that as well.
I see. Okay, great. Yeah, I want to end with one sort of bigger picture question. So, we kind of everybody's talking a lot about sort of full stack ML, end-to-end ML ops. Everybody's talking about this, and everybody wants to sort of get this skill set. And of course, the skill set is very different, as in your diagram, or just write to Amazon SageMaker, or write to Azure, or you hop on Vertex and you just like, and is that's sort of end to end in a sense, where it's one click deploy, one line deploy in a notebook. Everybody's sort of building these streamlined tools. If somebody's getting started, a learner getting started, wants to get into data science, machine learning engineering, ML ops engineering, do you encourage them to pick up the one-click tool first? Yes. Yes.
I worked, I've been on every side of the fence, and, on the fence, under the fence. Okay, so my point is, the more you learn, the more you know, the faster you can spin the wheel, okay? Because unfortunately, some data scientists stay and live in the notebook, and then, okay, they have a model, so they push that model to a Git repo, and that's where it stops for them. But for your customers and your business stakeholders, nothing has started until the model is live in prod. So, I keep saying an okay model in production will beat a great model in the sandbox every single time. So if you want to maximize your impact, if you want your projects to move faster than everything else, you need to be able to do as much as you can yourself, okay? I mean, no one wants to create Jira tickets and wait for the models to be deployed. You know, again, for some very, very regulated companies, that's how it works because they have no choice. But for most companies and startups, come on, you know, every hour you waste is an hour you waste. So I don't want to, you know, I'm not going to say every data scientist needs to become a guru DevOps person, okay? Just like every guru DevOps person is not going to become a guru ML engineer, you know, everybody has their preference and their experience and their skills, and that's fine. But I think now we're getting to a point where those tools are so easy to use all the way to production that at least for the POC stage, I believe there's no excuse not to do it yourself, okay? If your company doesn't want you to do it, that's a different story. Of course, you got to follow rules. But if you have the flexibility in your org to go all the way in a controlled way, of course, but POCs and sandboxes should be fine. You need to be able to do that because within a single day, you can deploy, test, analyze problems, train again, redeploy, etc., and iterate fast, right? And then, okay, you have a model that you like, and then I'm sure you have a very, you know, tightly controlled deployment process for prod, and that's the way it should be, unless you're a crazy startup. So, well, all rules are off, and that's okay too. But for a normal company, there's a process, and then, yeah, you need to get somebody's approval to deploy. But generally, on the day for your daily work, you need to know a little bit about that. So learn a little bit about SageMaker, learn a little bit about Azure, learn a little bit about JCP, learn a little bit about all the cool ML platforms out there. You know, not just us, and be, you know, you can be your own DevOps engineer up to a point, and that'll save you time.
Love it. Such a great way to end this, you know. So thank you all out there for all of your great questions. You know, thank you, Julien, for joining us. You know, this brings us to the end of today's event. We hope that you've enjoyed your time and that you've taken a few lessons with you for the road that are going to help you in your next ML project. You know, FourthBrain is so grateful to have the opportunity to showcase Hugging Face in this event and in our courses. You know, both our machine learning engineer program, our machine learning operations program, and our new MLOps short course incorporate aspects of their ecosystem that we got a glimpse of today. So check out fourthbrain.ai for more info on our upcoming MLE and MLOps course offerings. Our next 16-week program starts in just 9 days on June 18th, and our new 4-week MLOps short course starts next month on July 5th. That's all for today. We look forward to bringing you more events like this one soon to help you along in your ML journey. See you next time.
Thanks again. Bye-bye.